In this lesson, we will talk about the classification of matter. You have already learned what is matter. Matter is anything that has mass and occupies some space. And now what we are going to discuss is how that matter is organized. We can classify matter by looking at its composition. Does it have variable composition? You can have answer yes or no, right? If it is yes, it's a mixture. If your answer is no, it's a pure substance. Now, does the mixture has visibly distinguishable parts? If your answer is yes, it is a heterogeneous mixture. If your answer is no, it's a homogeneous mixture. There are two types of pure substances as well. Does it contain various types of atoms? If your answer is yes, and if your answer is no, then this will differ. So if your answer is no, it's an element, and if your answer is yes, it is a compound. While watching this video, compare elements and compound using this Venn diagram. You can draw this Venn diagram in your notebook and write down all the points on elements and compounds and what is in common as well. Let us explain each type of matter in detail. Pure substances are also called as substance, simply substance, and the definition for pure substance is it cannot be separated by physical means. And all pure substances are either elements or compounds. So example for element, anything that you can see in the periodic table. I took the example mercury here. All pure substances are composed of one type of atom. You can see here the molecular level is made only one type of atom. So the particle representation is shown as filled circle here. It can be a triangle or any other shape. Okay, so in this case I showed the filled circle. If the pure substance are formed by chemical combination of two or more substances, it is called a compound. You already know the example water. It is a combination of hydrogen and oxygen in a fixed ratio. In the particle representation, this is shown as filled circle with a different color because it's a combination of two different elements. It's chemically combined, so it is a compound. It can be separated but only by chemical method, not by physical method. For example, water can be separated into its constituent elements, which is hydrogen and oxygen, using an apparatus called Hofmann electrolysis apparatus. We are supplying electricity to split water into hydrogen and oxygen. So hydrogen gas will form on one column here by passing electricity, and oxygen will go in another column. So you can split the compound, but not physically, but chemical method. Here we used electrolysis, that means by passing electricity. While watching, be sure to take notes on graphic organizer to compare now the homogeneous and heterogeneous mixture coming up. You know, in our daily life, mostly we encounter with the matter which are not pure substances. For example, the air we breathe, gasoline we burn in our car, the sidewalk we walk on are not chemically pure. These are called mixtures. Mixtures are composed of two or more substances that can be separated by physical means. It can be elements, any other form, it can be solid, liquid, it doesn't matter. Mixtures that are not uniform throughout are called heterogeneous mixtures, and those mixtures which are uniform throughout are called homogeneous mixture. Another word for homogeneous mixture. Homogeneous mixture are also called solution. A solution is composed of solute and a solvent, as you know. A solute is a substance being dissolved, and the solvent is the medium in which the solute is being dissolved. Solvent is present in large amount. For example, sugar solution is made of solute sugar and solvent water. Sugar solution is a homogeneous mixture, as we already mentioned. It will retain the properties of sugar and water. This is not a chemical combination, as you can easily evaporate the water out and can get the sugar back, or you can separate this mixture by distillation. We will discuss distillation in the upcoming slide. Sugar solution looks uniform throughout, so it is a homogeneous mixture. Similarly, air looks uniform throughout, so again it's a homogeneous mixture. However, air is made of different components like oxygen, carbon dioxide, water vapor, etc., as we already discussed. So it is definitely a homogeneous mixture. Here are some examples. And now, if two or more metals are combined, it forms an alloy. See that this is physical combination. So here is an example. So amalgams are special type of alloy that the dentists were using amalgam to fill the cavity. And another example for a homogeneous mixture, which is also called solution, is brass, that's an alloy, bronze, it's an alloy. These are examples for homogeneous mixture, and they are a special classification called alloy because they are basically a mixture of two or more metals. Can be sometimes non-metals too, but alloys are combination of two or more metals which are homogeneous mixture, which is also called solutions. If the mixture is not uniform throughout, it is called a heterogeneous mixture. Heterogeneous mixture is made of two or more substances physically combined. For example, breakfast cereal in the picture is a heterogeneous mixture here. The particle diagram is as shown here with a different color and combination. You can see that triangle represent one type of element, circle another element, green another element. So these are all separate, but this is combination of everything. So this is a compound, these are all elements. So it is a mixture now. Similarly here, this is a compound, this is a compound, but different types of compound. So it's a mixture now. Here also you can see element and compound. So it's a mixture. You can see that this is just like Mickey Mouse water. So I can say salt being dissolved or sugar being dissolved in water. So that is a homogeneous mixture when you dissolve it. But now it is shown as not dissolved. So it is, you can see that yellow dots and the water droplets separate here. You can see that. So it is, since you can see different substances clearly, you can call it as heterogeneous mixture in particle representation here. And now compare pure substances and mixture when you watch the next slide. Now read this question and write your answer in your notebook with a justification. The question says, some students used a variety of procedures to investigate 4 liquid samples. The students recorded the following information. When sample W was cooled, solid particles settled out of the liquid. The mass and volume of sample X were measured, and the density of sample X was calculated to be 1.6, let me get my highlighter, 1.6 grams per milliliter. Okay, they calculated the density. And sample Y was heated and the temperature was recorded. All the liquid boiled away at the same temperature. That's important. At the same temperature, everything boiled off and left no residue in the container. While when a dilute acid was added to sample C, gas bubbled and rapidly rose to the surface of the liquid. Based on this observation, which sample was clearly identifiable as a pure substance? So you have to pick the pure substance. Okay, so which one is that? And when they say sample W, it's cooled solid particles. When you cool it, solid particles settle out. So liquid evaporated, just like we said, we can separate salt from water. So that is what? A homogeneous mixture. And now the next one says, the mass and volume of sample X were measured and the density of the sample calculated. They got a density, but we don't know which one they are talking about, right? And they calculated the mass, and so how do we know? Without giving a comparison, we don't know is that density matching with any pure substance or not. So let's see the next answer. Sample Y was heated and the temperature was recorded. All the liquid boiled away at the same temperature and no residue left. So what do you think from that? And when a dilute acid was added, that's the way you have to analyze the question. And now write your answer. And let's check the answer after you have noted down in your notebook. Did you get the answer? Which one you picked? Is it sample Y? Because no residue left in the container after heating. That means everything evaporated at the same temperature. So that's pure substance. Alright, we can move on to the next lesson.